Hi guys, today we learned some of the basic points of the theory of computation. So if you like this video, hit the like button and also hit the subscribe button for getting more upcoming videos from my side. Okay, so what are the basic theory of computation basic points? The theory of computation consists of three main parts, that is language, automata and grammar. If you know about language, if you know about automata and if you know about grammar, you will know most of the parts and most of the theory. Okay, so what is language? Language is made up of symbols, various kinds of symbols. Okay, so a list of finite symbols is called an alphabet, denoted by sigma, that is this one. Okay, so a finite list of symbols is called alphabet. Now alphabet can be denoted by sigma AB. It means that it has two input symbols or two alphabets. Okay, two input symbols A and B. Okay, it will not have any other input symbol. Okay, and what is a string? String is a sequence of alphabets or collection of alphabets. So this is an a collection of this is an alphabet. Okay, and a collection of alphabet is denoted by a string. Okay, and what is sigma AB? It consists of alpha strings like AA, AB, BA, BB. Okay, so these are all strings or collection of alphabets. Okay, but this will only have a length of 2. Okay, since it consists of only two alphabets. And if you want to make a collection of strings, or say a collection, if you want to make a collection of strings having three alphabets, then you can make it as this way: a b a b a b b b a. Okay, so what is language? Language is a collection of strings. So these are all strings, and a language is a collection of strings. So suppose write L1 equal to strings of length 3 or length 2. So this is an example of a finite language because it mentions that it should be of a length 3 or of length 2. Okay, languages can also be infinite. For example, AAA, AAA, 4 A's. So this is an example of an infinite language. So if they ask you to write strings which start with A and end with A, write strings which start with A and end with A, then it can be of any string. It can be any string like AA, AAA, 4A's or ABA. You get the point. So this is an example of infinite language. Okay, and what is sigma to the power 0? That is epsilon. That is all strings with length 0. So not A and not B, not even A and not even B. So sigma 0 is an example. Sigma to the power 0 is contains epsilon, which is all strings with length 0. Now we go to language. Language can be finite or infinite, as I had already mentioned. Okay, so length 2, or at least alphabet of ending with A, so infinite languages. Now what is automata? So we finished language. Now we want to know about automata. Automata is basically a mathematical model or a machine. And automata can be of various types, such as FA, that is finite automata, or PDA, that is push down automata, or LBA, that is linear bound automata, or TM, that is Turing machine. Okay, so this is basically what is automata. Now if you want to know about alphabet, then alphabet, that is sigma to the power star, is known as uh, uh, sigma to the power star is known as clean closure. Okay, clean closure. So we come here, like, clean closure is known as sigma to the power star, which is an infinite language. So if they ask you in exams that what is sigma to the power star, then you should know that it's an infinite language. Then sigma to the power plus is known as positive closure, that is removing epsilon, or sigma to the power 0. Okay, and we can represent sigma star in the form of sigma to the power plus sigma to the power 0. Okay, so sigma to the power plus is equal to sigma to the power star minus sigma to the power 0. Okay, so basically sigma plus or sigma to the power plus or sigma to the power plus is known as positive closure, which is all strings or all alphabets, not strings, sorry, all alphabets removing epsilon. Removing epsilon is known as positive closure. Okay, and what is epsilon? Sigma to the power 0, as I had already mentioned to you before. Okay, now we go to grammar. Grammar is defined as a quadruple. Okay, and before that you should know that sigma star has sigma that is null. Sorry, sigma star has null, hence identity element exists. So this they might ask you in your competitive examinations MCQs, like does identity element exist in sigma to the power star? Then you have to say yes, because null exists in identity as an identity element, and sigma to the power plus doesn't have an identity element because it does not have null. Okay, so might be an important multiple choice question. And if you want to know about grammar, then grammar is defined as a quadruple. Okay? Grammar consists of variable, terminal, production rule, and start symbol. Okay, so four items are there, so hence it is known as quadruple. So what is a production rule? So this is example of a grammar. Okay, so this is the start symbol or variable. Okay, and these are the terminals a and b. Okay, these are terminals, and this entire thing is a production rule. Okay, so it can have values like epsilon or asb or aasbb. So I will explain to you these things about the grammar in the next upcoming videos. Okay, so if you liked my this video, hit the like button and also hit the subscribe button. Thank you.